Hello everyone, we're going to be doing section 7.2, which is on the inverse trigonometric functions. So this is a little bit of just a continuation of our last function, section 7.1. So we're still just continuing these inverse trigonometric function practices. So we have four objectives. One, that we want to define the inverse secant, cosecant, and cotangent functions. 2, find the value of inverse secant, cosecant, and cotangent functions. 3, find the exact value of composite functions involving the inverse trigonometric functions. And 4, write a trigonometric expression as an algebraic expression. So starting with objective 1, we want to define the inverse secant, cosecant, and cotangent functions. So the inverse cosecant, secant, and cotangent functions are defined as follows. So we see we have our list here. So starting with secant, we have y is equal to secant inverse of x if and only if x is equal to secant of y, where the absolute value of x is greater than 1 and y is between 0 and pi, including 0 and pi, but actually not including pi over 2. So that the domain that we're looking at is between 0 and pi. Then for y is equal to cosecant inverse of x is if and only if x is equal to cosecant of y, where the absolute value of x is greater than or equal to 1, so our range is between -1 and 1, and y is between negative pi over 2 and pi over 2, including negative pi over 2 and pi over 2, but not including 0. So that would be our domain. Then lastly, y is equal to cotangent inverse of x, if and only if x is equal to cotangent of y, where x is between negative infinity and infinity, so that range is between negative infinity and infinity, and y is between 0 and pi, not including 0 or pi. So these are our definitions of our inverse functions for secant, cosecant, and cotangent. Then for objective 2, we want to find the value of inverse secant, cosecant, and cotangent functions. So we gotta find the exact value of these inverse trigonometric functions for some numbers, but other numbers will need calculators. Most calculators don't have inverse cosecant, secant, or cotangent, so you have to use their reciprocal function set equal to the reciprocal input. So we'll go over what that means in a little bit here. So example 1, if we want to find the exact value of each expression, we're looking at 3 different expressions. We have A, which is equal to the secant inverse of 1, B, cosecant inverse of -4, and C, cotangent inverse of negative square root 3. So starting with problem A, we have A is secant inverse of 1. So knowing what we know about secant, we're going to do what we did with our other problems where we found exact values for expressions. We have secant inverse of 1, so we're going to let theta equal secant inverse of 1 for theta in between 0 and pi. Where theta does not include pi over 2. So now that we have this, we want to go ahead and find our theta value. So we're going to take secant of both sides. When we take secant of both sides, this gives us secant theta is equal to secant of secant inverse of 1. So because secant and cosecant, cotangent are just the inverse or reciprocal of our original trig functions, we can still use the same identities as before. So when we have secant of secant inverse of 1, this is still going to let us equal 1. So if we have secant theta is equal to secant of secant inverse of 1, this really still just gives us secant theta is equal to 1, where we still have that 0 is less than or equal to theta, which is less than or equal to pi, and theta is not equal to pi over 2. So we have secant of theta is equal to 1. We know that secant of theta is just going to be 1 over cosine, so we're really just considering when cosine is going to be equal to 1, because then this would give us the value of 1. So in this case, the only angle in this range is going to be 0, since we know that cosine is equal to 0, or cosine of 0 is equal to 1, so then secant theta would be equal to 1 since it's 1 over cosine. So the only angle in this range is going to be 0, so that means that secant inverse of 1 is equal to 0. So all right, let's go ahead and do number part B. So for part B, we want to do the same thing. We're going to let theta equal cosecant inverse of -4. So we let cosecant inverse of -4 be equal to theta, which this means that when we go ahead and define our domain first, which will be between -π/2 and π/2. Where theta does not equal 0. Then we want to go ahead and do the same thing, take cosecant on both sides. When we do, we get cosecant of theta is equal to cosecant of cosecant -4, cosecant inverse of -4, which we know just gives us -4. So we're looking for these values here. All right, so we know that there's some value of theta that has to give us cosecant of theta is equal to -4 when theta is in this interval and not equal to 0. We know that cosecant is just going to be 1 over sine theta. Cosecant of theta is also equal to 1 over sine of theta. So now we're saying that 1 over sine of theta is equal to -4. But now if we actually want to find sine of theta, which will make this problem easier, we now have to take the reciprocal. So if we have 1 over sine of theta is equal to -4, when we take the reciprocal, this is going to end up giving us sine of theta is equal to -1 over 4. So now we have this value of sine of theta is equal to -1 over 4. This is what we're going to have to use in our calculator. We don't actually know the actual value of this, so we will have to use our calculator to find the value. But since we don't have inverse, cosecant, secant, or cotangent, we have to use the reciprocal function set equal to the reciprocal input. So our reciprocal function now being sine of theta set equal to the reciprocal of the input, which was -4. So now we have sine of theta is equal to 1 over -1 over 4. So now that we have this, we want to go back, we want to backtrack a little bit because we want to find theta, remember? So we don't know off the top of our heads, we don't have like an easy, simple way to find out what values of sine of theta would give us -1 over 4. We're going to have to use a calculator. But when we use our calculator, we have to input this now as theta is equal to sine inverse of -1 over 4. So now this is the value that we're going to have to put into our calculator. So here we're going to use Desmos. We're going to use Desmos for this part, so let's pop on over there. All right, so we had sine inverse of -1/4. So if we go to Desmos to our scientific calculator, if we go over here to function, we see that we have our sine inverse function here. So we'll click sine inverse, go back to our main. So now we're taking the inverse sine of some value. So we need to put in -1/4, so we'll put in our minus sign, and then we'll say 1 over 4. So you can either find how to put in a fraction, but, oh yeah, here it is. So you can put in a fraction this way, or the easiest way is to do the forward slash. But so we have sine inverse of -1 over 4. And this gives us a strange answer. We get this negative 14.47, and it just doesn't really seem right. And it doesn't seem right because we're not in radians. Our answer needs to be in radians since we see that our range and our domain is in terms of radians. We need to make sure that we're in radians. So we click that button, and now we get an answer that makes quite a bit more sense. Now we have negative 0.2526802551. It's only necessary to round however many decimal points something asks of you. For our problem, let's round to 2. This would end up giving us a negative 0.25, which is coincidentally negative 1/4. So let's go on back over to our notes now. All right, so from Desmos, we found that sine inverse of negative 1/4, which we found was equivalent to cosine inverse of negative 4, was about negative 0.25. So we can say that cosecant inverse of negative 4 comes out to about negative 0.25. So that would be our answer for part B. I'm actually just going to scoot over a tab. All right, so now on to part C. So we need to scoot this over a little bit, so we're going to go a little bit wider than we normally would. For part C, we have cotangent inverse of negative square root of 3. So just as before, we're going to let theta be equal to cotangent inverse of negative square root 3, where we see that our value of theta is going to be between 0 and pi. So we let theta be equal to the inverse cotangent of negative square root of 3. We want to do the same thing as we've done every other time. We're going to take cotangent of both sides. So that will now end up with a cotangent of theta is equal to cotangent of cotangent inverse of negative square root of 3. Where our domain is still the same. So 0 less than theta less than pi. So this simplifies down to just be cotangent of negative square root of 3, theta between 0 and pi. And now that we have this, there's only one value in between or in our interval that would end up giving us this value here. So there is only one angle. In our interval. That would give us this, which is going to end up being 5 pi over 6. So this means that cotangent inverse of negative square root of 3 is then equal to 5 pi over 6. Yeah, there we go. So, all right, that was how we would find the exact value of each expression. So we did go over how you would do one in a calculator, and every other one was just found mostly by using the unit circle and the values there.